In this video, we're going to discuss inverse function. Before we learn the inverse function, we need to know what one-to-one function is, because we can only find the inverse function if it is a one-to-one function. So, one-to-one function means the function will not have the same value. If inputting different variables. Just like a function, we call it fx. Then it will be fx1 not equal to fx2. We can have an example of x squared and x cubed. We can try -1 and +1 inside the function. We just do a brief calculation of the function. As the result, x squared produces the same value but x cubed not, so it is the most simple example to show one-to-one function. And x squared is not a one-to-one function, but x cubed is. The notation of inverse function is like f-1 of x. The definition of inverse function is based on one-to-one function, which means the only x will produce the only y, such that the original function is y equals to fx, and it implies that input x to get y. And the inverse function is y equals to the inverse of fx, which means input y to get x. And we will talk about later why we don't write this as x equals to fy. And we can have a drawing of the relationship between original function and inverse function. We have the function of x power of 3. The left hand side is x variables, and the right side is y variables. And we're using the white to present original function and red for the inverse function. For the original x cubed, we're inputting x to find the y. So we input the left hand side and the x cubed, and it will produce the right hand side value. If we can find a function of inputting y to get x, then it is the inverse function of x power of 3. And we are seeing the answer now, which is cube root of x. And after we learned how to inverse the function, we'll go back here and try the same method to inverse it. Here has an interesting story about the domain and range between original function and inverse function. So, domain of original function is equals to range of inverse function. And obviously, the range of original function is equals to the domain of inverse function. Let's do two examples of the inverse function. The first example is y equals to square root of x plus 6. Then we can find the domain and range of this function first. If we want to solve the domain of this function, we need to do the equation of x plus 6 is greater or equal to 0, because the value inside the square root can't be negative. It only exists 0 or positive in the real number. We just minus both sides and we will get x is greater or equal to negative 6, such that the domain is from negative 6 to infinity, which includes negative 6, and the range of the function is from 0 to infinity, which includes 0. The reason is same as before. The square root can't be negative in the real number. And we are doing the inverse now. We square it both sides and it will have y squared equals to square root of x plus 6 squared. When the square root and square meet, then they can cancel out, such that we got y squared is equals to x plus 6. And we leave x alone, so we minus 6 both sides, and we have x is equals to y squared minus 6. Finally, we'll exchange the x and y variables. So here is the reason why we don't use x is equals to fy, because we are familiarized to use x be the independent variables and y to be the dependent variables. So the inverse function of square root of x plus 6 is f negative 1 of x equals to x squared minus 6. And we find the domain and range of this inverse function now. Notice that the domain of original function is equals to the range of inverse function. And the range of original function is equals to the domain of inverse function. The domain of inverse function is from 0 to infinity, which includes 0. And the range of inverse function is from negative 6 to infinity, which includes negative 6. The second example is y is equals to x squared plus 10x plus 25. So we do the factorization first. We write down two brackets first. We use quadratic formula to solve it. The quadratic formula is negative b plus or minus square root of b squared minus 4ac divided by 2a. We just input the value inside it, so we get negative 6 plus or minus square root of 10 squared minus 4 times 24 divided by 2. Then we only have negative 10 divided by 2, such that we got negative 5 and x equals to negative 5. x is equals to -5, which means there are 2x plus 5 after we factorize it, and -5 is the real root. We rewrite it as y equals to x plus 5 squared. So we got the y equals to fx form. Now we can do the inverse. We take a square root both sides, and we can have square root of y equals to x plus 5. It is same as previous example. We can cancel the square when the square root and square meet. And we leave x alone. Then we can get x is equals to square root of y minus 5. We interchange x and y, then we can have the inverse function of x squared plus 10x plus 25 is f -1 of x equals to square root of x minus 5. And because it is an algebra function and it don't have the limitation, so both domain and range are from -infinity to infinity for the original function. The domain and range of inverse function is the same, from -infinity to positive infinity. And we go back x power 3 case. So y equals to x cubed. And we take cube root both sides. Such that we have x equals to cube root of y. Then interchange x and y. So we got y equals to the cube root of x, which is the same as our previous answer. If you like my video, please click the like button, share and subscribe. You may also leave your comment and let me know to improve it. See you in the next video.